Hi everyone, what's up? Welcome back to my CapMath tutorial channel. Daniel's here and today I'm making my second video in probability and SMPA preparation. And my lesson today will be talking about conditional probability and independence. So the objectives. Firstly, I would like to talk about the difference between conditional probability and unconditional probability. Then I will be talking about multiplication rule, Bayes rules, Bayes theorem, and independent events. So let's get started. So you have learned in the first video about sample space and probability. You have learned how to construct a sample space, how to define an event, how to compute probability. So today we go to a very new concept, which is conditional probability. So what is the difference between conditional probability and the regular probability? Let's look at an example. Situation 1. In a group of students, there are 2 boys and 3 girls. The teacher wants to select 2 students. One is rewarded $50 and one is rewarded $30. So the first question, what is the probability that the student who is rewarded $50 is a boy? This question is basically to the regular probability. We have 5 students, 2 boys and 3 girls. The probability that the student who is rewarded $50 is a boy, that means the probability of getting a boy out of the group of 5 students containing 2 boys and 3 girls. So we have 2 boys out of 5. So the probability is just 2 out of 5. So 2 over 5 is the answer for this question. And this is an example of unconditional probability, the regular probability. Now we go to the second type question. What is the probability that the student who is rewarded $50 is a boy, given that the student who is rewarded $30 is a girl? So you see the second question is pretty much similar to the first question. However, we are given an additional information, which is given the one who is rewarded $30 is a girl. So in this question, we assume that another event has already occurred. That means we assume that one student has already received $30 and that is a girl. So because we have already selected one student, so we have only 4 students left, and amongst the 4, we have 2 boys and 2 girls. So the probability of getting a boy out of a group of 2 boys and 2 girls is just 2 out of 4. So in this situation, it's not 2 out of 5, but 2 out of 4 because one girl is already omitted. So we have only 2 boys and 2 girls left. The probability of getting a boy is just 2 out of 4. And this is an example of conditional probability. That means the event when we are given an additional condition. And the keywords to recognize the type question is just given. So whenever you read a context, you read a textbook, you read a question, and they give you an event given another event, that means they are mentioning conditional probability. So pay attention to the keyword. Now I would like to mathematical modeling the problems. So we have just differentiate between conditional probability and unconditional probability. Now how do we compute the conditional probability? So mathematical modeling the situation. Let A be the event that a boy is rewarded $50 and B be the event that a girl is rewarded $30. And we treat the 2 events separately. We're not assuming anything occurs. So the event A is a boy is rewarded $50. So the probability of A is just choosing a boy out of a group of 2 boys and 3 girls. So it's 2 out of 5, 2/5. And the probability of B is 3/5 because we want to choose one girl out of the group of 3 girls and 2 boys. Now the probability of the probability that a boy is rewarded $50 and a girl is rewarded $30. So this event is two event occurs at the same time. So the probability of a boy is rewarded $50 is 2/5. However, the probability of girl is rewarded $30 in this situation is not 3/5. So let's look at the answer. Probability of A and B in this situation is 2/5 times 3/4 because the probability of getting a boy out of a group of 2 boys and 3 girls is 2/5. Then after 1 boy is already selected, we have 1 boy and 3 girls left. So in a group of 1 boy and 3 girls, the probability of getting a girl is 3 out of 4. So the answer is 2/5 times 3/4, which is 3/10. Now we go to the conditional question, the conditional probability question. So probability that a boy is rewarded $50 given that a girl is rewarded $30. So the answer is 2/4. We have done this problem from the previous slide. So here if you pay attention to these numbers, 3/5, 3/10, and 1/2, we see that there is a relation. There is 3/5 times 1/2 is 3/10. So our conjecture is probability A given B times probability B is probability of A and B, because probability here is 3/5 and probability of A given B is 1/2, and probability of A and B is 3/10. So that is the relation, our conjecture. And if you divide both sides of the equation by probability of B, we have probability of A given B is probability of A and B over probability of B. A new notation here is probability of A given B is probability of A flash B. So please make sure that you learn the notation, because on the context, on the textbook, or any question on the exam, you will see probability of A given B sometimes, not probability of A given B. So we have constructed the formula for conditional probability. Now we go to the definition. Let's A and B are 2 events and A is a positive event. That means probability of A is not 0. The event B given the event A is the event B occurs in case event A has already occurred. And to compute this probability, the probability of event B given the event A is notated as probability of B flash A, and it is a conditional probability and defined as probability of B flash A is equal to probability of A and B over probability of A. So here this is conditional probability formula. Now if we multiply both sides by probability of A, we have another formula that is multiplication rule. So we go to multiplication rule. Multiplication rule is very simple. It's just it's almost identical to conditional probability, which is rewrite the formulas. So let's A and B are 2 events and A is a possible event. Rewrite the formula of conditional probability of event B given event A. We obtain the multiplication rule as follows. So probability of A and B is probability of B given A times probability of A. And similarly, if we interchange A and B, that means if assuming that B is also a possible event, probability A and B is also the same as probability of A given B times probability of B. To obtain this formula, we basically write out a formula of probability of A given B is probability of A and B over probability of B, and then divide both sides by probability of B. So that is about multiplication rule. Now we pay attention to these 2 equations. we see that the left hand side is identical to the left hand side, so for sure the right hand side of these two equations are the same. So probability of B given A times probability of A is equal to probability of A given B times probability of B. So now if we divide both sides by probability of A times probability of B, we have one more relation, that is the ratio probability of B given A over probability of B is the same as probability of A given B over probability of A. So this is one more relation. Now we go to Bayes' rules and Bayes' theorem. First, I would like to introduce law of total probability. Probability of an event A is probability of event A and B plus probability of event A and B prime. Don't forget that B prime is the complement event of event B. So think about this just like A is the group of boy, B is the group of people who like pink color, and B prime is the group of people who doesn't like pink color. So AB is the group of boy who like pink color, and AB prime is the group of boy who doesn't like pink color. So the group of boy is just like divided into two groups, boy who like pink color and boy doesn't like pink color. So probability of A is probability of AB plus probability of AB prime. It's very simple. Now the next step, we are going to apply the multiplication rule into the right hand side of this equation. So on the right hand side we have two intersection events. The first term is probability of A and B. The second term is probability of A and B prime. So we are going to use multiplication rule one by one. So probability of A and B is probability of A given B times probability of B plus probability of AB prime is probability of A slash B prime times probability of B prime. So that is the law of total probability. Now we are going to construct the Bayes rules. So we start with the probability of B given A. By conditional probability formulas, we have probability of B given A is probability of AB over probability of A. And we are going to apply the law of total probability into the denominator. So, excuse me, basically we bring the whole equation 2 into the denominator. So at the denominator, probability of A is probability of A given B times probability of B plus probability of A given B prime times probability of B prime. So we have the Bayes rules. Now we go to the extended formulas of Bayes rules and Bayes theorem. So at the basic formula, we work with only two events A and B. And B and B prime are the two complement events of each other. So basically, they're also a partition. It's just like B and B prime are mutually exclusive and they combine together to be the whole sample space. So now suppose we have more than two events to make up the whole sample space. That means the partition contains more than two events. So it's standard form. If A1, A2, and to AN form a partition of the entire sample space S, then probability of an event HA given B for NHA, I assuming for NHA from 1 to N. So probability of an event HA given B is probability of HA and B over probability of B. This is by conditional probability. Now we are going to apply multiplication rule into the front, into the numerator, and the law of total probability into the denominator. So at the numerator, probability of HAB is probability of B given HA times probability of HA. And at the denominator, we apply the law of total probability. We have probability of B is probability of B given B and A1 plus probability B and A2 plus dot dot to probability b and an. So we think about the denominator, it's just like the general law of total probability. We think about the case like B is the group of boy, A1 is the people who like number 1, A2 is the people who like number 2, to AN is the people who like number N. So the group of people divide into N group, the group of boy divide into N group. The boy who like number 1, the boys who like number 2, the boys who like number N. So we combine these N group together, we have the whole group of boys. So that's about general total probability law. Now we are going to use summation notation to rewrite these formulas. So at the bottom, at the denominator, if we rewrite the whole thing by the summation formulas, we have probability of AJ given event B is probability of B given event AJ times probability of AJ over the summation of probability of event AJ and B. So this is the general base form or the extended form. And notice that the general law of total probability is at the denominator. Probability of event B is the summation of probability of event AJ and B. So that is about Bayes' rules and Bayes' theorem. Now we go to the last point of today, that is independent events. I drop a typos here. It should be independent events. I hope it's not gonna be amusing here. So independent events, lesson 2 is kind of short, so we don't have much to talk about, but I would like to go over more practice problems. So independent events, first we start with only 2 events. 2 non-empty events A and B are said to be independent if probability of A and B is probability of A times probability of B. That means the probability that A and B occurs at the same time is just the products of the probability. Another way to think about this is probability of A given B equal to probability of A, or probability B given A is the same as probability B. That means like whether B occurs or not occurs, the probability of event A to be occurred will be the same. And whether A occurs or not occurs, whether the probability of event B to be occurred will be the same. Now we go to the general formulas of independent events. So mutually independent of events. Events A1, A2 to AN are said to be mutually independent if the probability of event A1 and A2 and A3 and AN is the same as the products of probability. So we use by notation, we have probability of the intersection of AJ of these N events is the same as the products of the probability of these N events. So that is about independent events. We have some more rules concerning conditional probability. The first rule is probability of AB is probability of A given B times probability of B and equal to probability of B given A times probability of A. So this is just basically multiplication rule. Rule number 2, we extend it into more than 2 events. So probability of A1, A2, A3, and AN is probability of A1 times probability of A2 given that A1 has already occurred times probability of A3 given that A1 and A2 have already occurred times dot dot dot. So it's just like if you are choosing a number out of a group of number. So A1 is the event of choosing the first number. And then event A2 when we have already chosen the first number is A2 given A1 and so on. Rule number 3, conditional form of complement rule. So remember, by complement rule, the unconditional formulas, we have probability of A prime is 1 minus probability of A. So the complement rule also apply for conditional probability. So probability of A prime given B is equal to 1 minus probability of event A given event B. Rule number 4, conditional form of additional rule. Remember, in additional rule, what we have learned in the first video, we have probability of A or B is equal to probability of event A plus probability of event B minus probability of event A and B. So here is also applied for conditional probability. So everything we need to do is just like add in the ending of slash C. So probability of A or B given C is equal to probability of A given C plus probability of B given C minus probability of A and B given C. Rule number 5, if A is a subset of B, then probability of A given B is probability of A and B over probability of B. This is by conditional probability. And A intersect B, because A is a subset of B, so A is inside B. So when it's intersect with B, we have just A. So that's the ratio of probability of A over probability of B. So that is everything about conditional probability. Now let's do some exercises. The first problems. An actuary studying the insurance references of automobile owners makes the following conclusions. The first conclusion, an automobile owner is twice as likely to purchase collision coverage as disability coverage. The second conclusion, the event that an automobile owner purchases collision coverage is independent of the event that he or she purchases disability coverage. The probability that an automobile owner purchases both collision and disability coverage is 0.15. And the question is, what is the probability that an automobile owner purchases neither collision coverage nor disability coverage? So remember, at the first lesson, I have already told you that when you work with probability, don't forget mathematical modeling the problem. Don't forget to model the problem mathematically using notation, because when you look at the whole context like this, like a bunch of words, if you don't try to summarize the question using mathematical notation, you're gonna be confused and you don't know where to start. So first, make up notation. And don't forget the tip when you make up notation. Make sure you make it simple and easy to remember, that you don't have to get confused over the problems. Here we have two events, that is purchasing collision coverage and purchasing disability coverage. So I'm going to call C represent for collision coverage and D for disability coverage. So by using C as the event that an automobile owner is purchasing a collision coverage, and D is the event that an automobile owner purchases a disability coverage, I have these information. By the first information, an automobile owner is twice as likely to purchase collision coverage as disability coverage. So that means probability of C is 2 times probability of D. That is the first information you have to write down quickly. Now we go to the second conclusion. The event that an automobile owner purchases collision coverage is independent of the event that he or she purchases disability coverage. So that means probability of C and D is probability C times probability of D. This is by the property of independent events. Next conclusion. The probability that an automobile owner purchases both collision and disability coverage is 0.15. So that means probability of C and D is 0.15. And the question asks for what is the probability that an automobile owner purchases neither collision coverage nor disability coverage. So that is so the question asks for the probability of neither. Now from the first in the third information, we have probability of C is 2 times probability of D, and probability of CD is 0.15. So we use the third line information. We can find probability C is 0.548 and probability of D is 0.274. This is very simple. I think it's simple because probability of C and D is 0.15, and that is the product between probability of C and probability of D. When probability of C is 2 times probability of D, so basically probability of C and D is 0.15, and that's equal to 2 times probability of T squared. So from that information, we can find probability of D and probability of C. Now the question asks for probability of neither. So the chance that an automobile owner purchases neither collision nor disability coverage is 1 minus the probability that an automobile owner either purchases collision or disability coverage. And don't forget the additional rule. Probability C or D is probability of C plus probability of D minus probability of C and D. So that is 1 minus 0.274 is probability of D, 0.548 is probability of C, and 0.15 is probability of C and D. And from here we have calculation, some calculation, and it's just simply 0.328 and round it to 0.33, and the answer is B. So this is a very simple question. You see that if you did a mathematical model this question, if you didn't mathematically model this question, you will not know where to start, and you're gonna get confused when you work on the problem. So my suggestion, my advice is, first, try to notate the question using some simple notation. Make it as simple as possible, and then write out all of the information that is given, and then find out what the question asking you for, and then solve for it. So that's the first problems. Now we go to the second problems. An insurance company examines its pool of auto insurance customer and gathers the following information. The first information: all customers insure at least one car. 70% of customers insure more than one car. 20% of customers insure a sport car. Of those customers who insure more than one car, 15% insure a sport car. Calculate the probability that a randomly selected customer insures exactly one car and that is not a sport car. So here we have two groups of events. The first group is whether a customer purchasing insurance one car or more than one car, because all customers insure at least one car. So we either have exactly one car or more than one car. So I'm gonna say A is the event that a customer insure exactly one car. So A prime is a complement event, which is a customer insure more than one car. And from that information, we can write out probability of A prime is 0.7, because the question said 70% of customer insure more than one car. That means probability of A prime is 0.7. So by complement rule, probability of A is 0.3. By general speaking, it's just like 70% of customer insure more than one car, and because all customer insure at least one car, so we have 30% of customer insure exactly one car. Now we call B is the event that a customer insure a sport car. So B prime is just an event that a customer insure a car that is not a sport car. So because from the third information, 20% of customer insure a sport car, so we have probability B is 0.2, which is 20%. So for sure 80% of customer insure a car that is not a sport car. So we have probability B prime is 0.8. Now the last information you have to pay attention. They said of those customers who insure more than one car, 15% insure sport cars. So this is type question of given event. That means given the customer insure more than one car, 15% insure sport car. So we have probability B given A prime is 0.15 because insuring sport car is even B. Purchase more than one car is even A prime. So probability of B given A prime is 0.15. And the question asks for calculate the probability that a randomly selected customer insures exactly one car and that is not a sport car. So that means probability A and B prime. A mean insure exactly one car and B prime mean insure more a car that is not a sport car. So that's how we mathematically model the question by notation. So now let's take a look back. We have probability of A prime, probability of A, probability of B, probability of B prime, probability of B given A prime, and we need to find probability of A, B prime. So by the first information, probability of B given A prime, we use conditional probability. We have probability of A prime and B over probability of A prime. But probability of A prime is given, so from here it's easy for you to find probability of A prime and B. And we found out is 0.105. So here's the thing. You look at the question again. The question asks you to find probability of A, B prime. And you have found out probability of A prime B. So how do you find A, B prime when you're given A prime B? Think about a middle is like another connection. So from A, B prime, we can make connection with A, B by law of total probability. And from A prime B, we also can make connection with A, B. So our conjecture is using A, B as a tool to make connection between A prime B and A, B prime. So by law of probability of total probability, we have probability of B is probability of A and B plus probability of A prime and B. Here probability of B is given, probability of A prime and B we have found from the previous slide. So we would be able to find probability of A and B that is 0.095. And here we have found AB. And we need to find AB prime, so use one more law of total probability. So we have probability of A equal to probability of AB plus probability of AB prime. Here probability of A is given. Probability of AB we have found from the previous slide. So we have probability of A and B prime is 0.3 minus 0.095, which is 0.205. So that is probability of A, B prime, and the answer is B. If we round up to 2 decimal places, 0.205 is 0.21. So answer B. You see that? So again, like for any type question related to probability, first make sure that you have to set up notation, write out all the information in terms of mathematical notation, like summarize the question and then make connection between the information with what is not given and what is given, and find a way to solve for what the question asks you for. So that's question number 2. Now we go to problem number 3. An insurance company pays hospital claims. The number of claims that include emergency room and operating room charges is 85% of total number of claims. The number of claims that do not include emergency room charges is 25% of total number of claims. The occurrence of emergency room charges is independent of the occurrence of operating rooms charges on hospital claims. Calculate the probability that a claim submitted to the insurance company includes operating room charges. So here we have two types of room that emergency these are emergency rooms and operating room. So we are going to use two letters E and O to represent for emergency room and operating room. So let E and O be the events that a claim includes an emergency room and operating room respectively. That means E is the event that a claim includes an emergency room, and O is the event that a claim includes an operating room. So now one by one, the first information is the number of claims that include emergency room or operating room charges is 85%. So or that means probably E or O is 85%. So the first information is probably E or O is 0.85. Next information, the number of claims that do not include emergency room charges is 25% of total number of claims. So that means probability of E prime. E is the event of including emergency room. So E prime is the event of not including emergency room charges. So it's probability of B prime is 0.25. Probability of E is 0.75. Now the last information, the occurrence of emergency room charges is independent of the occurrence of operating room charges on hospital claims. So we have probability of E or E and O is probability of E times probability of O. This is multiplication rule. No, this is independent event rule. So the question asks for the probability that a claim submitted to the insurance company includes operating room charges. So that means the question asks for probability of O, the probability of O. So here we think about we have probability of E or O, and we have probability of E prime, probability of E, and we need to find probability of O. So think about additional rule, because we have or and we also have and we have is events. So here by additional rule we have probability of E or O is probability of E plus probability of O minus probability of E and O. So probability of E or O is given as 0.85, probability of E is 0.75. Probability of E and O is probability of E times probability of O. So let's write out one more line. So here we have a new equation. 0.85 is equal to 0.75 plus probability of O minus probability of O times probability of E. And don't forget probability of E is already given, which is 0.75. So we have we write one more line. Now this equation is just an equation of only one single variable, and this is a linear equation, so it's very easy to be solved. So we solve for probability of O and we got the answer is 0.4. This is very easy. So I don't want to show you how to how to solve a linear equation because it's just too basics. So we have got the answer D. The probability that a claim submitted to the insurance company includes operating room charges is 0.4, which is 40%. So that's problem number 3. You see that the question is very long, but then the solution is very short, because that's how we try to use notation to mathematically model the question and try to make it simple. So once you know how to use notation to summarize the question, the problem would look very easy. Question number 4, a blood test indicates the presence of a particular disease 95% of the time when the disease is actually present. The same test indicates the presence of the disease 0.5% of the time when the disease is not present. So here this is kind of like we are given the probability of given event, because they said when and when. 1% of the population actually has a disease. Calculate the probability that a person has the disease given the test indicates the presence of the disease. So here you see that to define whether a person has a disease, we have the actual, that means the reality, and we have the test. So sometimes the reality say that the person doesn't have a disease, but the test show that the person has a disease. And sometimes the reality say that the student does have a disease, but the test show up like positive. So this is kind of like in biostatistics, we see this question pretty much like very often, really often. So here we are going to summarize the question. Since we have reality and we have the test, so I must say let D be the event that the disease is actually present. That means in reality, um, the person really have disease, and T is the event that the test indicates the disease is present. So by the first information, we have like a blood test indicates the presence of particular disease 95% of time when the disease is actually present. That means T given D. That means in reality, given the reality that the person really have the disease, the probability that the test show up that the person has disease is 95%. So probability T given D is 0.95. Now the same test indicates the presence of disease 0.5% of the time when the disease is not present. So that means in reality, the disease does not present, but is not present, but the test show up that the disease present. So probability T given D prime. And we are given one more information. 1% of the population actually has disease. So that means probability of D is 0.01. That means they're talking about reality because you see the word actually. Actually mean about reality. So calculate the probability that a person has a disease given that the test indicates the presence of the disease. That means probability of D given T. So it's like calculate the probability that in reality the person really have disease given that the test show that that person has a disease. So when you are asking about conditional probability, make sure you know that the only thing we can use is conditional probability formulas. So probability of D given T is probability of D and T over probability of T. So now let's take a look at what we have found out. We have probability of T given D. We have probability given D prime. So think about the law of total probability, and they are given probability of D, and they ask for probability of D given T. So to find probability of D given T, we need to find two things. The first thing is probability of D and T, and the second thing is probability of T. So here's the thing, by law of total probability, probability of T is equal to probability of T given D plus probability of T given D prime. So that is the first thing we can find. Probability of T equal to probability of T given D times with probability of D plus probability of T given D prime times probability of D prime. And from that we found out probability of T is 0.01445. And now we are going to find probability of D and T. So use multiplication rule. Probability of D and T is probability of T given D times probability of D, and that is 0.0095. And from here we find the answer. Probability of D given T is 0.0095 over 0.01445, and the answer is 0.657, which is B. So B is the answer. So you see that whenever you are given two given events and they look very similar, like probability of T given D and probability of T given D prime, we think about one connection, that is we have like this is called Bayes rule. So probability of T is probability of T given D times probability of D plus probability of T given D prime times probability of D prime. So it's just like the probability that the test show up disease is probability that we have the test show up disease in case that the reality is given the disease, and in case the reality does not given disease. So that's how we make connection of the information that is given. Alright, so that's question number 4. Now we go to problem number 5. Published health researchers examined the medical records of a group of 937 men who died in 1999 and discovered 210 of men died from causes related to heart disease. Moreover, 312 of 937 men had at least one parent who suffered from heart disease, and of those 312 men, 102 died from the causes related to heart disease. Determine the probability that a man randomly selected from this group died of causes related to heart disease, given that neither of his parents suffered from heart disease. So here we have whether the man died from the disease and not from the disease as one group of events, and we have whether the man has at least one parent who suffer from heart disease or not is another group of events. So here I call X. Let X be the event that a man died from heart disease. So that means X prime is the event that a man died from different causes, not heart disease. P is the event that a man has at least one parent suffer from heart disease. So B prime is the event that a man does not have any parents suffer from heart disease. Now we are going to write out information one by one. The first sentence, a published health researcher examines the medical records of a group of 937 men who died in 1999 and discovers 210 died from the causes related to heart disease. So that means probability of H is 210 over 937 because we have 937 men died, and among them we have 210 died from heart disease. So probability that a man died from heart disease is 210 over 937. Next, we have moreover 312 of 937 men has at least one parent who suffer from heart disease. So that means probability of P is 312 over 937. And one more information, they said like and of those 312 men, that means of those men who have at least one parent suffer from heart disease, that means given that the man has parent suffer from heart disease, 102 die from the causes related to heart disease. So probability of X given P is 102 over 312. Now the question has asked for determine the probability that a man randomly selected from this group died of causes related to heart disease, given that neither of his parents suffer from heart disease. So that is probability of X given P prime, because X mean die from heart disease and P prime mean doesn't have any parents suffer from heart disease. So now let's take a look back. We have mathematically modeled the problems. So we are given probability of X, probability of P, probability of X and given P, and probability of X given P prime. So don't forget one thing. Probability of X is probability of X given P times probability of P plus probability of X given P prime times probability of P prime. And here probability of X is given, probability of X given P is also given, probability of P is given, probability of X given P prime is what we need to find, and probability of B prime can be found by 1 subtract probability of P. So probability of X is 210 over 937 equal to probability of X given P is 102 over 312. Probability of P is 312 over 937 plus probability of X given P prime is what we need to find, and probability of B prime is 1 minus probability of P, so 1 minus 312 over 937. So from here, it's just basically a linear equation of one single variables. So we find probability of X given B prime is 108 over 937, and the answer is 0.1728. So the answer B. Answer B. So you see that the question looked very complicated, but when you break down words by words and try to mathematically model the question, we see the problem is very simple. Next, problem number 6. The probability that a randomly chosen male has a circulation problem is 0.25. Males who have circulation problem is twice as likely to be smoker as who do not have a circulation problems. What is the conditional probability that a male has a circulation problem given that he's a smoker? So here you see that the first sentence gives you the probability that a person has circulation problem. Then the second information, males who have circulation problem is twice as likely to be smokers as who do not have circulation. So this is kind of like given event information. So we are going to call C representing for the event that a randomly chosen male has a circulation problem. C represents for circulation. And S be the event a randomly chosen male is a smoker. So here by the first sentence, we have the probability that a randomly chosen male has a circulation problem is 0.25. That means probability C is 0.25. Males who have circulation problem is twice as likely to be smoker as who do not have a circulation problem. So probability of S given C is 2 times probability of S given C prime. That means probability of being a smoker given circulation is 2 times probability of being a smoker given does not have circulation problems. So the question asks for what is the probability that a male has a circulation problem given he's a smoker. So that is probability of C given S. You see it, C given S. So here we have S given C, and then we want to find C given S. Remember, in multiplication rule, we have one rule that is probability of S given C over probability of S equal to probability of C given S over probability of C. So let's look at here. First, we derive the formulas of probability of S because we are going to make connection between X given C and X given C prime. So probability of S is probability of S given C times probability of C plus probability of S given C prime times probability of C prime. It's like the probability that a person is a smoker is, we have two cases. Smoker in case he has circulation problem and smoker in case he doesn't have circulation problems. And now we are going to replace probability of S given C by 2 times probability of S given C prime because that's what given from the second information. So that's equal to 2 times probability of S given C prime times with 0.25 plus probability of S given C prime times 0.75. So now we are going to combine them. We are going to factor probability of S given C prime out. So we have probability of S is 1.25 times probability of S given C prime because 0.25 times 2 is 0.5 plus 0.75 is 1.25. And don't forget that probability of S given C prime is 1/2 of probability of S given C. So probability of S is 0.75 probability of S given C. Now we are going to make connection between S given C and C given S. So don't forget that probability of S and C use multiplication rule is probability of C given S times probability of S, and that's equal to probability of S given C times probability of C. So from here we are deriving probability of C given S, that's equal to probability of S given C times probability of C over probability of S. And one thing that is beautiful here is probability of S is can be written in terms of probability of S given C. So we replace probability of S at the denominator by 0.75 times probability of S given C. Now probability of S given C and probability of S given C are cancelled out. So that becomes 0.25 over 0.75, which is 1/3. So the answer is B. The answer is B. So you really, for conditional probability, the formulas, like the formula is kind of very it's like um it's not easy to memorize, but it's not that hard. Like you really have to find a way to think about the formulas in words. Like try to think about, for example, probability of S equal to probability of S given C times probability of C plus probability of S given C prime times probability of C prime. It's like probably like for example, S is smoker, so we have two cases. C mean has circulation problem, C prime has doesn't have circulation problem. So in the first case, probably that a person has circulation problem is probably C. Then probably being a smoker given circulation is probably of S given C. So we multiply them together to have the first case, and do similar for the second case, and combine them together. We have probably of S. So that's how you like you really have to find a way to memorize the formulas by understanding the formulas. Like what does it mean, like what does the formula talking about, not just like okay S and C, C and S, but what you have to learn is how to make connection between the formulas in the real life situation that will make you understand and memorize the formula better. So thank you so much for watching, and I hope you guys enjoyed my video. The topic today is not long, but is like it's harder than the first one because we are dealing with so many given event, and it's a little confusing because sometimes we have A given B, sometimes we have B given A, and sometimes we have A and B. So I hope you if the lesson is too hard, I recommend you to watch the video again and try to stop my video whenever you feel like you are getting lost, and try to write down and like try to work it out, and when you got that part then move on, keep watching the next part, and then try to get you to how you work with probability. All right, thank you so much, and see you guys on the next video. Bye bye.